Hello, this is Mrs. Scarpel, and in this video I'm going to go over how you can solve quadratic equations by factoring. The first thing I want to remind you of is if you're going to solve by factoring, the equation must be set equal to 0. So if you're given a quadratic expression and is equal to a constant value or another expression, you need to make sure to get everything on one side of the equation so that it's equal to 0, and then you can factor and solve. Now when we solve by factoring, we want to factor the expression. And as I look at this x squared minus 9x plus 20, I see that it is a single x squared. So I don't need to worry about multiplying a times c, because a times c is just going to be the 20 as anyway. So I'm going to start by drawing my area model. And in my area model, I know that I have x squared in the upper left, and I have a positive 20 in the lower right. What I want to look for are the factors of 20 that are going to add to give me negative 9. Now I know that 5 times 4 multiplies to give me 20, and 5 plus 4 adds to give me a positive 9. So if I want to get a negative 9, both the 5 and the 4 need to be negative, and just to verify that this works, negative 5 times negative 4 does equal a positive 20. So we have a negative 5x in our model, and we have a negative 4x in our model. Then we can find our factors. To multiply and get x squared, that's going to be x times x. When I multiply x times negative 4, I will get negative 4x. When I multiply the other x by negative 5, I will get the negative 5x. So in factored form, this equation is x minus 5 times x minus 4. And it's equal to 0. Now if you're wondering where that 0 came from, it's because our original expression was set equal to 0. Now, something that we've talked about in class is when we have y equal to 0, then we can find x-intercepts. Well, in factored form, we can find x-intercepts. So when you're solving from factored form and it's set equal to 0, what you're doing is you're identifying the x value of your x-intercepts, because the equals 0 is like saying equals y, but we've replaced y with the 0. So my x-intercepts are going to be 5 and 4. So my answer is going to be 5 or 4. And I say or because when we take the square root of a constant, we get a plus or minus, telling us that we could have two possible answers when I take the square root. So that's why I write the word or. Our next equation is a quadratic trinomial again, but this time I have a leading coefficient that isn't 1. So first thing I'm going to check is, do my other terms have coefficients or constants that are multiples of 3? 14 divided by 3 is not going to be an integer. 5 divided by 3 is not going to be an integer. So for this particular problem, I am going to have to use the process of 3 times negative 5, a times c, is negative 15. So what we're going to look for are factors of negative 15 that add to negative 14. Now, even when you do this a times c method to find out what you're looking for factors of, those factors are always going to add to that second term every time. For 15, we have 3 and 5. That's not going to get me anywhere close to a 14. Or we have 1 and 15. And I can use 1 and 15 to get negative 14 when adding if the 15 is negative. So when I go back up to my factors, 1 and 15, if I make the 15 negative, positive 1 times negative 15 does equal negative 15. So I'm going to draw my area model. And in my model, I know I'm going to have 3x squared. I know I'm going to have the negative 5. We use the constant, the c value, from the original problem, not from when we take a times c. And then I use the negative 15 and the 1 to fill in the other two spaces. These two spaces are always like terms, and they're always going to add to give us the middle term. Now what I'm going to do is I'm going to think about what number goes into both 3 and 1. That's going to be 1. So I'm going to multiply 1x times 3x to get 3x squared. And I'm going to multiply 1x times 1 to get 1x. 3x needs to multiply with something to give me negative 15x. Well, 3 times negative 5 gives me negative 15, and since I have the x on my 3, that takes care of the x. And then just to verify that our factors of 1 and negative 15 work here, giving me 1 and negative 5 outside. 1 times negative 5 does equal negative 5. So this factors as 3x plus 1 times x minus 5. Now, if we think about x-intercepts like we did on the last problem, one of them should be easy to identify, and that's the x equals 5 intercept. For the other one, the 3x plus 1, if we want to find out what x is for the intercept, I need to set that expression equal to 0. So 3x plus 1 equals 0. To undo that, I have to subtract 1. So we have 3x equals negative 1. And then I need to divide both sides by 3. So we have an intercept of negative 1/3. So our solutions to this problem are x equals negative 1/3 and x equals 5. And the last one I'm going to go over is 2x squared plus 8x minus 42. Now before I take a times c like I did in the previous example, I'm going to see if the 8 and 42 can be easily divided by 2. Since they are both even numbers, I know that is going to be the case. So the first thing I'm going to do is factor out a 2. That's like doing the distributive property backwards. To get 2x squared, I would have to multiply x squared with the 2. To get 8x, I would have to multiply 4x with the 2. And to get negative 42, I would have to multiply negative 21 with the 2. So 2 is one of my factors, but I don't need it as I factor the expression x squared plus 4x minus 21. So if I start with my area model, and I enter the first term of x squared and the constant of minus 21, because this is a 1x squared, I can just start with what are my factors of negative 21 that are going to add to equal 4. Well, my options are 1 and 21 or 3 and 7. Well, 1 and 21 are not in any way, shape, or form going to add to get me 4. So if I take a look at the factors 3 and 7, I need the 4 to be positive. So I'm going to subtract the 3. And if 3 is negative, when I multiply it with the 7, I get negative 21. So we have a negative 3x, we have a positive 7x, which means I'm going to have x times x to get x squared. It'll be a plus 7 times x to get 7x. It will be a minus 3 times x to get negative 3x, and we already confirmed that 7 times negative 3 is negative 21. So my factored form, don't forget, factored form still has that 2. So we have 2 times x minus 3 times x plus 7. Now, that 2 doesn't have a variable. Remember, if we're talking about a graph, that 2 tells me the stretch. In this case, my graph will be narrower. If I want to know my x-intercepts, I just need to look at my factors. One of them is going to be a positive 3, and the other is going to be negative 7. So we have x equals 3 or negative 7 as our solution to this problem. And this concludes the video on solving by factoring.